A rapid energy transition is needed to meet the requirements of the Paris Climate Agreement. In response, over 140 countries have an ambitious net zero emissions target. Governments across the globe are developing energy policies to support a rapid transition. But a rapid energy transition has several key obstacles. These obstacles must be carefully considered to ensure a bright future. Ignoring or downplaying them will lead to poor energy policies and thereby a poor outcome. Welcome, I'm your host, Tushar. I have over 25 years of experience in the energy field. This includes technology development, commercialization, and evaluation. For more information, please visit my website. In this episode, we'll review two key obstacles to a rapid energy transition: timely access to critical minerals and timely access to land. The other obstacles will be addressed over the next few episodes. A rapid energy transition involves a rapid shift to a low carbon energy system. Essentially, it requires a rapid transformation of our whole energy system. What does this mean in physical terms? The net zero by 2050 proposal by the International Energy Agency provides data about this. The annual electricity produced from solar and wind power will need to grow from about 4,000 terawatt hours currently to 55,000 terawatt hours by 2050. This is supermassive because the global annual electricity from all sources combined is only about 29,000 terawatt hours currently. The global electricity networks will need to more than double over the next 30 years. Why is this a big deal? Because the total current length of transmission circuits and distribution grids is over 80 million kilometers. Battery storage will need to increase from about 50 gigawatts today to 4,200 gigawatts by 2050. The annual production of hydrogen from low carbon sources will need to increase from trivial amounts today to over 400 million tons. Overall, today the use of low carbon energy technologies is very low. A supermassive growth will be required in all the energy areas by the year 2050. This includes electrification of transportation, buildings, and heating applications for many industrial processes. Such a massive transformation is indicative of serious obstacles. Why? Because such changes will require enormous amounts of resources at a very rapid pace. We'll first examine the obstacle related to critical minerals. Critical minerals are elements or materials that are at high risk for supply disruption and are required for important applications. Example applications are high technology devices, defense applications, and energy technologies. Low carbon energy technologies require a wide range of critical minerals. I'll discuss a few examples. Cobalt, lithium, nickel, manganese, and graphite are important for battery performance. Wind turbines and electric vehicles require rare earth elements. Electric networks require large amounts of aluminum and copper. Abundant access to critical minerals is crucial for low carbon energy technologies. This is because low carbon technologies require several times more critical minerals than conventional technologies. Solar power requires 16 times more critical minerals compared to fossil fuel power to produce the same amount of lifetime electricity. Onshore wind requires 12 times more critical minerals, while offshore wind requires 14 times more. An electric car requires 6 times more critical minerals than a conventional car. A heat pump requires 7 times more critical minerals than a conventional gas boiler. A timely access to critical minerals is not an issue currently. This is because the current use of low carbon technologies is trivial to small. However, as I discussed earlier, a rapid transition will require a supermassive increase in the use of low carbon technologies. This will lead to an enormous increase in the demand for critical minerals. Based on the net zero pathway proposed by the International Energy Agency, there will be a massive jump in critical minerals demand from the year 2021 to the year 2030. Low carbon technologies will require 3 times more copper, 4 times more cobalt, 8 times more neodymium, 10 times more nickel, and 14 times more lithium. Many new mining projects will be needed to provide the critical minerals required for a rapid transition. Why is that a major concern? Because recent data on certain relevant critical minerals shows an average of 20 years of lead time for a new mining project. This data from the International Energy Agency is based on the analysis of major mines that became operational between the years 2010 to 2019. Exploration takes about 12 years on an average. Construction of the mine and ramping up production requires another 8 years. Furthermore, the commercial success of the mining project is not guaranteed. For example, not all projects move from exploration to the next phase. So such projects carry a high financial risk. Although the activity in this area has increased significantly, there is a high likelihood that the supply will not keep up with the demand. A recent analysis by the International Energy Agency is revealing. It shows that the anticipated supply of several critical minerals will be well below the demand set by the net zero target. The overall data indicates that a timely access to critical minerals will be a major obstacle to a rapid energy transition. We'll review the obstacles related to the required land resources next. Solar and wind power plants require far more land than natural gas and coal power plants. A solar power plant requires over 100 times more land to produce the same amount of lifetime electricity as a natural gas plant. A wind farm requires several hundred times more land. Total land requirements will be large because of the massive increase in solar and wind power. Recall, the IEA net zero pathway calls for the electricity from solar and wind power to increase by almost a factor of 15 by the year 2050. To be clear, the obstacle is not that there is not enough land. It is about the timely access to the land at the desired locations. The solar and wind power projects often need to be sited close to the population centers for economical and other practical reasons. Many people are opposed to having such projects close to where they live. Globally, there is an increasing level of such not in my backyard sentiment. Energy projects are increasingly seeing pushbacks from the local communities. A rapid transition will require many new renewable energy projects, grid expansions, and new mines. This will massively increase the total land requirements. The pushback from the local population will make it very difficult to get timely access to the required land. A recent Columbia Law School study about the situation in the United States is revealing. Renewable energy projects have faced significant opposition in 45 states. Over 200 local laws and policies have been issued in 35 states to restrict renewable energy projects. The not in my backyard problem has been on the rise globally. This problem impacts all projects, not just low carbon energy projects. But the challenge is especially severe for the low carbon energy transition because of its massive land requirements. Very few renewable projects have been deployed compared to what is proposed in the future. Even so, the opposition for the projects has been significant. Several times higher deployment is being proposed over the next 3 decades. This will markedly increase the severity of this obstacle. A quick recap. Rapid access to massive resources of critical minerals and land will be required for a rapid energy transition. Timely access to critical minerals is a major obstacle because of the very long lead times and financial risk associated with new mining projects. Timely access to land resources is a major obstacle because of the opposition local land use, which results from the not in my backyard sentiment of the local communities. That's it for now. I'll discuss the other major obstacles over the next few episodes.